All right. So I think this thing is on. Sorry if should be okay. Let's see. If we can get that going. Let's move this over here. Hey. Oh wait, no, I can speak. Sorry. Hey man, how you going? I'm hoping that the audio is kind of in sync a little bit, but I'm busy. Oh, awesome. Oh, hey, how you going? Hey. Oh, nice. Awesome, man. Looking forward to it. Oh, busy can be good. Helldivers. Oh, I saw that. I've read quite a bit about that game. It's fucking funny, that introduction video. It's good, really, yeah. I saw, I've read a bit about it, like about how the history of it is interesting, you know, like the independent company that actually developed it, like they started off with like, there was Helldivers 1 and it was like not very successful, not very well received. And then this second one was like very well done. And it's, it's very interesting. Like how it was developed as a live service first, and how like it's kind of a cool example of a live service game and all that sort of thing. I find that kind of interesting. In a weird way, I don't even play. I think I don't even play video games anymore. But I did when I was a teenager. But I still love like hearing about it, and I'm almost more interested in like how they're made and how they run than actually the game itself, in a weird way. And I love reading about the stories and the art direction and all that. But I never play them. It's so, yeah. But okay. So we have a interesting and Trav. Oh, I can't wait, mate. My RSS feed is constantly being refreshed. So I finally got some like a real sort of thing going with all of our stuff. I kind of accidentally did it, and I should have obviously done it like live, because that would have been interesting both for me and for others, I think. I probably would have made a lot fewer mistakes if I was doing it with other people, but hey. Actually, same number of mistakes, just not as long in between mistakes. So, this is a command I call AUTX, which is audio transmit. And what this program does is it reads raw audio from the standard input and transmits it over RTP to some particular destination. It works. So I've, basically, this is the IP address of a machine on the network, and this is the port that we're going to go. So this is, we're finally like testing out this thing to see if everything, kind of makes sense. Like all this logic that we did both in SDP and RTP. It's, So I'll walk you through it. So the first thing that we do is we create a description of the session so that a receiver knows like what to do with it. It knows like what it actually is going to look like. So you can kind of go through and see what's going on. Right? We're doing, well, the very first thing is that we're setting the clock rate. So this is the, in RTP and SDP world, it means the specification is whatever the sample rate of the audio is, that's what the clock rate should be. This is used for the receivers to understand the timestamps in their packets. Okay, that's the first thing. Hopefully this isn't too delayed between when I'm speaking and when I'm pointing at the screen and stuff. All right, we create the description. So we're going to say, hey, we're going to, we're boring stuff like where the connection is going to come from, the unique identifiers of the session, which are not super important, but, we sort of have to set it to be spec compliant. The interesting bit, of course, is the media here. So we're saying, hey, this is where the connection is coming from, and this is the content of the, this is what the session is going to be, yeah, this is the actual media. Okay, we're doing audio, doing port 9999. I should probably pull out more of these, but anyway, we're doing it over RTP. This is this is the rule. You say, hey, like the payload type, the RTP payload type must be put in the format here. That's the rule. And the attributes. So this is saying, hey, like this is characterizing the actual audio that you're going to be receiving. So first of all, we say, okay, well, we're going to be, again, getting the payload type L16. This is 16-bit linear PCM audio. And we describe it further. We say, okay, it's going to be, yeah, like the actual codec or non-codec as the case may be. But anyway, the clock rate, which remember is also the sampling rate. So here is actually the sample rate, and how many channels. We've got 2 stereo. So this is a bit yucky how this is done now, and this this needs to be a constant, and yeah. But anyway, yeah, I just kind of vomited this out. Okay, get rid of our debug. Right, now we actually do some very fun concurrent programming, and it seems to work very beautifully. And you sort of, the first time you write it, you like amazed that it works the first try, but hey, So we make an out channel, which is actually a queue, okay? Because we're doing a buffered channel, so we're saying, okay, hey, keep 100 packets in the buffer. So we've got one go routine, one sort of, process, whatever you want to call it. One process that's reading in the data and packetizing it. And then we've got another process that's transmitting all the packets. So this process over here is actually, reading the bytes and basically just like, kind of encoding the packet. There's not much to do. All we do is we just set the packet payload. See here. And then it sends it out through the out channel. And then and because it's buffered, it'll kind of load as many as it can, so it'll read as quickly as it can. And up until some level. And then sends it out. Okay. Now, the other process is using a ticker, because the rule is they say, okay, hey, if you're transmitting audio with RTP, the packetization rate, or the interval, sorry, should be 20 milliseconds. That's just what they say. It should be that. It doesn't have to be that, but it should be that. You can do anything between 20 and 200, I think it was in the spec. but I've just chosen the sort of default. So every 20 milliseconds, we read a packet from the queue, from the channel, and then we just transmit it. And that's it. So, I have some uncompressed audio that I found on the internet, and I'm going to get this camera out and see if this works. So just let me know if this is clear, by the way. Like, I don't know if the audio is okay. I don't even know if... actually, let me just quickly check, because, yeah. All right, so let me get this camera out, because this is going to be a very live demonstration. I'm going to unplug the power. This is the battery. All right, so first up, thing back going. All right, so we're going to start the listener, right? Okay. Now we're going to run our program somewhere. Whoops. Whoa. Hold on. What? Part of the stream just crashed. Okay, so we'll try again. So we're gonna, oops, I need to write mine. Hold on, let's get this. What was it called? Oh, yeah, we can get rid of that. Okay. So let's, I'm gonna hold that camera here, and I'm going to, let me just restart this. Okay, here we go. So running, okay. So we've not got, oh. Let me build up a bit of a buffer. I'm going to pause it and just, there we go. So it's got a little bit more in the queue now. So it's got about 150K. So if it drops some packets, it's, it's okay. Oh. Great music. Don't mind something about the yeah, pretty cool. Oh, and then did it reach the end of it? Yeah, nice. Okay, there we go. So let's Best viewers on, oh, fuck off. All right. Let's try again. That. Now, one of the things I want to fix up is my calculation of buffers and stuff like that, because I'm not super happy with it, I guess. Yeah. So what I mean by that is like, yeah. So the buffer size here, I've kind of gone, okay, well, I know that the size of it has to be, because I know my bit rate is fixed at 14.41 kilobits per second. And I know that I'm transmitting every 20 milliseconds. So that means that the number of bytes that I actually, go to that, number of bytes that I actually read in has got to be that many. So that's how many I want in the payload. But I don't know. It doesn't feel quite right to me. In particular, why is because I've got my little calculations here. Oh, by the way, there's our SDP file. So that I actually like manually copied to this machine here. So yeah, as I say, not quite happy with it. I want to. That should be a constant in the RTP package for one thing. But it's cool, like this is great because I've found a few like kind of things that would make the package a lot nicer. And yeah, and so it's been great, especially to verify the timestamp logic is kind of tricky. But it seems to be working okay. In particular, this method on the session here does quite a bit of the heavy lifting. So it does a whole bunch of like timing and stuff like that. That means that you don't have to care about it. You just send packets. As long as you set the clock, then we're okay. So what I was saying about this is that that's the size of my buffer right now. So that's how many bytes are going to be in the payload. The thing is that because between this computer and this one, right? Between this one, yeah, we're doing, it's UDP, IPv6 over Ethernet. That means that if I do, using my camera is like kind of, it's kind of easier to do it like this, I guess, but yeah, like doing 35, 20 bytes is going to get fragmentation. So the number that I've got in my head is 1280. Yeah, I kind of, yeah, because I don't want to fragment the packets, right? I'd just rather, so what I might do is just, so let's go again. Okay, I'm gonna that up. We're getting buffer underruns now, see? Hold up. See that? So we're not sending it enough bytes. Let me put this on a tripod. Give me a sec. This is the cool thing about doing it over IP, right, is that I can just move the camera around however I like. Oh, well, fucking camera wasn't even plugged in anyway. Like power, I mean. This. That audio is so fucked. Alright, we're charging. Here. Just Alright. Oh, okay, so there we go. Let's kill that. Interesting, right? So what we could do is maybe bump this up a little bit more and see, or at least try and work out something, you know, like try and work out something that is a little bit better. Let's say, don't know why that's struggling. Oops. So the listener, okay, run it. And then we run out of buffer. Yeah, see? So what's happening is that, I'm not sure if I can quite exactly see, but I'll do that. Okay. So if we change the buffer size to this again, it's kind of this, I mean, look, like this, it's either going to need to be smaller and we send the packets more frequently, or yeah, or yeah. Because if we don't send at least at that bit rate, then we're going to get buffer underruns. Let's try it. This is just to confirm. Yeah. I'm pretty much running real time here. There's no there's basically nothing in the
I know a little bit more now. See, so if I show you there,
Missing a couple of packets here and there, but okay, let's do another test. Let's send it every 10 milliseconds, which we can do because I've got this. So this computer here is over Ethernet, but this one is over Wi-Fi. So we're still okay. Like the latency is, you know, what are we like? Yeah, we're in about 1.5. Oh. Yeah, 1.7 milliseconds. So we're okay to do. We're okay to halve it down to 10 milliseconds. Let's see how that goes. Start this up. How does it know? How does this one know? So this one knows that the... That's because it knows the sample rate and it knows the bit rate, so it knows that it can... So there's an option, we go no inf buff. Oh. Okay. Let's now try to do it with, say, 50 milliseconds. We're definitely going to run out. So I'm expecting a very like staggered output now. So it's stuttered. So it's going to play and then I'm expecting it to run out of audio. Okay, here we go. Yeah. Yeah, because it's not, because we're only sending every 50 milliseconds now, so it's not getting enough information. Let's kill that. So what if we... Six. Yeah, so that's bytes. So I'll do this again, right? So we've got a 1411 kilobits per second. So in bytes per second, it's that. And then, so in kilobytes per second, it's that. So 176. So 1411. It's 1411. Yeah, and then that's per millisecond is. Yeah, really, I should have this as bytes. This doesn't seem right to me. No, this is wrong. Let's try again. I know it's 1411.2. It's that many bits per second. Right, 1411.2. Yeah. So we get that divided by 8 to get the bytes per second. Yep. So that's bytes per second, but we want to do per millisecond. So we get that. Yeah, okay. Yeah. And then, but we want to work out how much we should transmit per 20 milliseconds. So we can times that by 20. 3520, yeah, okay, so yeah. No, we'll right there. So what if I wanted to change it to... Okay, now let's do our calculations on the size of the bytes and stuff like that. Sorry, the size of the packets and all that. So I think we can go... let's just do a TCP dump here. I'll do 9999. Let's send, let's receive, got that running, let's send stuff, right? Yeah. Oh shit, whoops, hold up. Oh, I've got to change it to 20 milliseconds, so. Grab that. The packet interval. Okay, let's try again. This time we're going to read that. We're going to start the listener here. And we're going to send stuff now. Okay. Oop. Oh yeah, that's an interesting bug with this laptop, by the way. Like changing the brightness totally, it just like messes up the interrupts on the system. It's super weird. OpenBSD problem. Anyway, let's have a look at this. Let's turn this shit down. What? Is this not? What? There's no. What? Yeah. Yeah. So that's my video. Like this is my screen grab, so that makes sense, right? But what I'm missing is yeah. Makes sense. Oh, we're not going from... There we go. Yeah. Let's do this, right? And then let's do 10 times packet interval, right? That's really what we want. Well, except not, but we're going to do, yeah, 10. Okay, and then let's change this to 10. Do that. Let's do that. And hold on, no. It's getting because it's fragmented. Send it a little bit more often. Right, yeah. And take it down quite a bit. Let's do that. 14.1.1. Getting towards the... There we go. We can get it now because the packet isn't truncated, so I guess the snapshot length wasn't long enough for. Not enough data. Need more data, so they're doing it like this because, remember, this is uncompressed audio, so it's pretty big. Now, if it were half the size, as in if we just had one channel, then that would be pretty cool. Like if it was mono. maybe what we can do is, but yeah, no, that's actually, I mean, look, yeah, like I guess we're going to get, you know, with the MTU, so the max size of the packet that we can send over the network without fragmentation is like, you know, with IPv6 is like, yeah, 14 something. So, you know, yeah. So that means that, let's say we set this to 20. And let's set this to 24. Now we should definitely have more than enough, right? Because we're sending stuff every 20 milliseconds, but we're accounting for the fact that we're going to send that many. So let's send that. Let's just see what it looks like. I'm just going to set the host like this, just because hopefully that can catch it. Yeah, see? So what's happening is that it's got a lot in there. Now, if it drops a packet, yeah. Yeah, exactly, see? It's speeding up. I know. Okay, listen. IPv6, how 21st century. Oh, yeah. The reason why is because later today, oh, actually, speaking of which, what is the time? Let me check. And I'm good. Yeah, later today, like in about, I don't know, 6-7 hours, we're going to do a live demo with this, but like at a meetup. We're going to the Go Sydney meetup, and we're going to do a live demo where I'm just going to plug the two computers together with an Ethernet cable, and then we can just use IPv6. You know, do the link local address, and then without needing to, without needing to worry about anything. It should be pretty easy. Oh, you know people in Western Australia? Wow. Cool. Whereabouts are you? Oh, okay, cool. Oh, rocks. Oh, mining stuff, I guess. Oh, Silicon Valley. Yeah, okay. Oh, software. Okay. Yeah, but like mining software, maybe? Oh. Cool. Yeah, right. Yeah, okay, cool. Like, which, yeah, wow, awesome. Super interesting, man. Wow. Yeah. Fair enough. Gotcha. Yeah. Yeah, I bet EMC are very interested in deduplication. Let's just see what our at one point. Cool. Nice. And then did they move from Kim Nedham? Yeah, right, cool. Did they stay in Western Australia or did they move across to the California or let's see this again. Oh, they stayed. Awesome. Nice. Very I think it's a pretty similar climate actually in Western Australia, like in Perth. I assume they were in Perth, Western Australia, and that's sort of California. So dry and sunny. I mean, it's obviously it's sunny here in Sydney, but I mean, yeah, not like over there. There's no water over there. It's crazy. Mm-hmm. The company that bought them failed. Oh damn. They're in Perth. Yeah, yeah. Cool, cool. Oh wow. Interesting. So let's do that 21. There's a little bit of tweaking here, just to experiment, see what it kind of feels like. He'd like to grow his own food. Oh, nice. Only have 5 hours. Nah, it's fine. So it's interesting to watch. See, so this is pretty much what I'm expecting because I want to see that buffer slightly grow. Oh no, but then we miss a packet. So I'm kind of expecting to, because what we're doing is we're sending enough for 21 milliseconds in our packet, but we're sending the packets every 19 milliseconds. So yeah, it's kind of interesting. Go. But really, these should be the same. It's just interesting just to mess around with it and see how it works. Oh yeah, no, we're already doing that. Okay, let's go again. Now remember, there's no retransmission, right? So if we drop a packet, it's gone forever. So if there's any stuttering, there's nothing we can do to fix it. It's just gone. Slowly draining the buffer. There we go. So the buffer's gone on this side. We've got a lot up on this side. Oh, 500 followers. Holy shit. Seriously? Awesome. Woo. Thanks, everyone. That's awesome. Thank you. Hope it's interesting and useful. So, yeah, no, this is cool. So, yeah, definitely want to get mono audio. So, yeah. Well, yeah, you know, I mean, no, it's not a congratulations. It's like a, you know, you know, I'm super cool. Like when other people are inspired to do the same, because this is, you know, this is why I'm doing it, right? Trying to get more people to do stuff that isn't like just web dev, and, you know, get people to try and, you know, like explore, I don't know, like, yeah. And also to show like how, you know, like a relative noob like me can kind of still do something. Sorry, I'm speaking upside down. It's just because the camera's... All right, so let's hi, are you a he, him, or she, her? I'm a fully grown man. Nah, all good. You call me whatever. It's all good. Did you know in Indonesian, I'm learning Indonesian at the moment, and they don't have a she, her, or a he, him. It's just all dia. So you say like, computer dia means his computer or her computer. There's no, you know. Yeah, it's just true. You never know. I don't know about all that shit, to be honest. I'm not really good at that. I just like speaking to people, that's all. This is Acme from the Plan 9 operating system, but we're running Plan 9 port in OpenBSD, so catv.org. All right, so all right, this is cool. So I think what we're going to do now is we've found a few, you know, like a few bits that will make by actually using our. Sorry, let me put the camera like. Fucking, how do I turn this thing up? Where's the spinny? There we go. So, by actually using our code, we found ways. Oh, fucking hell! Let me get my back. There we go. All right. So by actually using our code, we found ways that like it could be easier to use, and, you know, like make it trickier to, you know, make it easier to avoid little mistakes. So in particular, what I want to look at is if we go payload types. Okay, so go to our, this is RTP now. I almost want to do a thing like a new file because this is just going to be a shitload of constants, but yeah, let's actually do a new payload. Go something like this one. Okay, oh no, that, and then package RTP. So payload type. There we go. See, yeah, see, we have some here. So let's go, we can actually just run it here, payload L16. And that's actually 10. So this is just something from the spec, just from, I think the original, the original RTP spec actually defined a whole bunch of things to transport, like different payloads that you could transport. It was originally designed for audio, you know, for phones, right? This is what, like for desk phones normally, you know. So let's do that. And then let's chuck this. So this is RTP.payload L16. So L16 is 16-bit linear PCM audio. We can do that there. Plan 9 is not the IDE I'd use, yeah. And we can start it up. I've got it in a VM running on this machine as well. It should be just, it would work fine for this kind of stuff. But yeah, I think it's tricky now, you know, with so much stuff going over the web and web browsers and stuff. It's very, yeah. Maybe we're okay here, we don't necessarily need that right now. Okay, so there's that, and then the other one would be this thing here, the media. So because there's only a few, like there's about 6 or so values that are set in the spec. So yeah, that's oh, sorry, no, that's in this is in the SDP package now. Yeah. Okay, so let's commit that, I think. We can do that separately. Leave that there. SDP. Okay. Origin. I'm surprised. The black one here looks exactly what I used to have, but we're running X-Men in a custom compile for Vim editor. Yeah. Yeah, well, I think there's actually some mathematics to this. It's explained in, I think this. So that man page in, I think, actually, wait, will I be able to? Yeah, no, it is. Yeah, here we go. When I color 3. 7. Yeah, no, here it is, color 7, yeah. So if I I can send a link. Pages. Color 7. No? Yeah, it is 6. Ah, because I'm not on plan 9. I'm in plan 9. Yeah, okay, all right. That's the sort of. That's the. Oh, let's see if I. Oh wow, far out. Crazy. Yeah. Yeah, and then yeah. 3551. That's the one for audio video minimal control. Okay, yeah, I'll. No. 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 Okay. Yeah, so yeah, there's some interesting theory about the way they slice up the colors, and that's how they got to this particular color palette. But I'm not good with all that color mathematics stuff like that, so I don't quite understand it. Okay, so we have what I wanted to do was get our media structure. Here we go. Type. Yeah, see, I knew I'd have it to do here for that. Yeah. So let's define a new type. I'm going to call it media type, and it's going to be a UN8, pretty sure. Okay, media type. Now I need to check, so I think it's RFC, which, what are we here? SDP 8866, okay. Oh, whoops, I haven't got my plumber. Okay, whatever, RFC 8866. This media name, media title, where was it? I can't remember. It's, yeah, it's this media thing here. Media descriptions. There we go. One, two, three, four, 5. For example, I received on 6. Okay, so there's 6. Maybe. Let's just do it. Let's do it like that for now, and then let's go. So, comms. Oh, we got it here. Okay. let's go through values: audio, video, text, application, message, and image. All right, so this. Okay, audio. Application, media type, message, and media type, image. That's what we've got so far. And then we'll do the T media type, and we'll just do some string on it. So okay, we'll go through all of these. Okay, at the beginning of each. Last I saw was a duck picture. So this is, we're doing, how's it going by the way? We're doing live audio, just because later in about 7 hours or 8 hours or so, me and my friend are meeting up at the Golang Sydney meetup in Australia. And he says to me, he wants to do some live audio thing. And I said, okay, well, that's fine. We can do that. I'm going to try and use my all this media sort of streaming network stuff that we've been doing. So I said to him, okay, let me just figure out best way to do this. I said, all right, I figured it out. I want you to send me 16-bit linear PCM audio at a sample rate of 44.1 kilohertz, and I should be able to transfer it over RTP and have something receive it over the network, and it should just work. So that's what we're doing, and that's what we've done, and it seems to work okay. We've just been fiddling around with the like the buffers, the timing, yeah, that sort of stuff. And yeah, I think it seems to be working like very nicely because, well, at least there's a lot of stuff that could be going wrong, but doesn't seem to be. It's obviously like a super difficult problem, right? Like there's a whole bunch of stuff that one of the things I'm really interested in doing is changing it to, right now I'm testing it with stereo. But I want to be doing mono because then I can get the, basically halve the payload size, and then that should be able to fit in a like a single Ethernet frame, which would be better for testing. So yeah, no, it's pretty cool. Now in the process, of course, what we've done is we've just found like a whole bunch of things that can be updated in our package, like little quality of life stuff, little sources of bugs, that sort of thing. But fortunately, the actual timing logic and stuff like that, where we calculate timestamps and packet numbers and stuff like that, is yeah, that seems to be okay, which is awesome. So when we transmit stuff over RTP so we have a thing called an RTP session, and there's a transmit method on it, and we pass a pointer to a packet. There's a bunch of sort of, heavy lifting that's done here. and we keep a bunch of state in the session, and that kind of updates itself and does whatever it needs to do. So, and that works okay, which is cool. We have not implemented a receiver, but that will be probably the next thing that will be pretty interesting. Right now, we're doing it with, we're doing FFmpeg on the other end. So this is one machine and this is a different machine here. So on this one, I'll just do a demo now. Assuming this is going to compile. Oh, give me a sec. I'll just... Yeah, okay, I'll just save this. Actually, let me just quickly finish this and then I will run the demo again. Oh yeah, that's cool. Yeah, it's great. Like, because we've switched over to doing like that, this camera does you know, it's wireless, right? So I've just got the power plugged into it, but it has a battery too. But because it's running over you know, just doing a MPEG transport stream over raw UDP to another computer, I can just move this thing around however I like. So that's kind of cool. And I've got the tripod and everything, so the other end is running. That is exactly right. Yeah. So what it's doing is, sorry. Let me quickly just write this bit of code just before I forget, and then I'll run thing. Just quickly. Okay, cool. That's working great. All right, let's go back to our demo. Okay, so let me put this to myself. Okay, so we've got this computer here, which is really... So here's the explanation of what's going on here. So we got this little computer under here. That one, that has little antennas, but they don't have a Wi-Fi, but it's our OBS machine that I use all the time. And that's got an Ethernet cable, which runs along here. And then this one is just, this is my ThinkPad running OpenBSD over Wi-Fi. Right. So, on this one here, we're going to run our little. So we're reading in this file here. So this file is a 16-bit linear PCM audio stream stored in a file. So it's just the raw bytes, uncompressed audio. We've written this little program called AUTX, or audio transmit. And all it does is it reads in from standard input and transmits to a particular address. It's just hard coded at the moment, but we can add stuff to make it, do that. So it's going to transmit to the this machine. So let me. Okay, so if I just simplify that. I'll explain what this one's doing now. So maybe I should just speak to it. Oh, no. You're going to want to see the screen, I guess.
So let me just... Sorry, let me zoom in.
All right. This one... sorry. Here. Oh, I'll just put that here. Okay. So we're running FFmpeg and we're giving it an SDP file that I've sent over from this computer. So that's also our package running nicely, right? Because we've been working on the SDP, a thing to work with SDP data. So that also works too. So this tells the receiver, hey, like here's, this is what the session's, what it's going to involve. And in particular, we've got here this L16 codec, and then we've got the payload type here. So that these are all RTP things. IP addresses, that's where we're coming from. And yeah, that's pretty much all there is here. This is telling us the sample rate, which is 44.1 kilohertz. So that's the same sample rate that you'll see on CDs and stuff. And we're saying that it's got 2 channels, so because it's stereo audio. And yeah, 16-bit linear. All right. So we start FFmpeg, or rather FFplay, say to it, hey, get ready to do whatever is in this file. And we do it. So let's start that. Should just do, let's get rid of the hide banner. There's so much noise. Okay. Waiting.
Let me see if that's running okay. Yep.
Okay, here we go. And so I can send the audio like this. Oh. Dropping a couple of packets. There we go. And so you can see, here's our SDP file. I just printed a standard error before we start. Yeah. Yeah. And then if I pause it, if I pause it like this and play, so it just keeps it all in the queue. So FFmpeg is, long is the audio file. Oh, how long, what's the duration of it? I think this one is like 2 minutes or something like that. Yeah. I just downloaded it from some like really shitty website online. Oh, there we go. Okay, it's done. Yep. There we go. And then see the process finished because yeah. Now, how this thing actually works is pretty cool because we've got 2 concurrent processes. Yeah, so we've got two concurrent processes on this machine. One actually reads in the bytes. So we've got two things going. One's reading, this one over here is reading the bytes in, reading like the raw audio bytes and packs it into a packet. And then it sends the packet into a channel. And the channel is actually a buffered channel. So right now we've set it to keep 100 packets in there. And that's it. That's all it does. So it itself is kind of, just independently doing that. Then the other process over here, this one is actually reading packets from the channel and then actually transmitting them out to, out to the network. And what we're doing is that how this actually works is we're saying, okay, this packet every 20 milliseconds we've set it to in one of the RTP specifications, they say if you're doing this type of audio transmission, you should transmit packets every 20 milliseconds. So we've, so that's, So what we do is every 20 milliseconds, we just read a packet and just blast it off. That's it. Why did I choose to decouple it? That's a good question. I think it just naturally happened because I knew that because I have all of the bytes in a file already, I know that I can read it much faster than I can transmit it. So I thought, okay, well, I want to just be able to read as many bytes as possible to kind of prevent any sort of, I don't know what, just, and not worry about, I don't know, something. So I kind of just naturally did it like that. And the other thing is that, it's sort of, I guess the other reason is that it kind of, I don't know, it just made it easier to signal between, to signal, hey, this thing's done and, so then stop transmitting or whatever. Using channels for that, it's and queuing and stuff like that, because in Go, you've got the channels and you can have buffered channels. It just gives you a natural queue without needing to do anything. I don't need to so yeah, it works really well. And signaling is just done by, you just close the channel and then the transmitting process goes, oh, okay, well, it's closed, so there's no more values. So and it drains the channel as well. So there's a whole bunch of stuff in the runtime in Go that kind of just, all of this stuff just naturally happens. So it's very, very, this, I think to me, this is Go's bread and butter, when you've got these, communicating processes, strong standard library, with the net package and the, the timer and of course the Go routines and the communicating processes. It's sort of, it's amazing what you can do in, I can show, this is the whole code here. There's nothing there, The stuff that's done in here in our RTP and SDP packages is very, it doesn't, there's not really that much going on there, in terms of they're really just doing the boring stuff of decoding and encoding stuff. So, it's really cool to be able to just deal with an RTP packet, which, because if I go up here, RTP packet, and I do an RTP header, so I can just deal with these types, which are pretty thin layer over the top of what's going on, but without all the noise of like all the packing and the, you know, yeah, all that sort of stuff going on. So yeah, it's yeah, so I don't have to, you know, all I do is I just set in the header, I set the type there. Everything else is actually by the session afterwards, which is, yeah, a different thing. We'll go into that. But yeah, no, it's pretty cool. Works, seems to work. So of course the next challenge is for my friend for him to get the actual he's writing a program in Zig to actually get the audio from a real microphone. So I think he'll go and he'll get the I can't even remember how he wants to do it, but I guess he'll get like a byte stream from ALSA, however you say it, you know, ALSA on. Oh wait, hold on. No, wait, is he running it on Linux or on his Mac? Anyway, but yeah, you get the idea, right? And the other challenge for him my input, of course, is very strict, right? Like it has to be. We can of course change it around, right? Like we can. If I just knock that out now. We can accept these sorts of things as input, like at runtime. So we can set like the sample rate of the audio. We can do, of course, the IP address of where we're going to, or just the address of where we're going to, the host and the port. Sample rate. Yeah, probably just that really, the sample rate, and maybe the, well, needs to be 16-bit audio. Yeah, but yeah. Yeah, because we've got some fixed buffer sizes and stuff that are based on, yeah, this is the bit rate of the uncompressed audio. That's the rate of the bytes, and then this is it per millisecond, or per 20 milliseconds, which is how often we're sending these things out. We can get rid of that. That, of course, is that. Yeah, we could, yeah. So one of the things that will make it nicer is if we do like this sort of thing, right? So we're going to get the audio, we need some more constants because these are kind of magic values. So we need to have these documented and all that, which is cool. So then we end up improving our little package. So when we parse it as well, we're now going to have some better error handling because we can, yeah, we're going to, anyway, let's, first let's stick with the payload type. Yeah. So let's commit that one because that's pretty easy. Right. Oh, is that it? Okay. Easy enough. All right. pretty easy. Okay. Now for this SDP, we're going to need to do some, some better parsing. So we're going to have, there's this function here where we actually parse the media line. Parse media, there we go. What is that? All right, here we go. Yeah. Okay. So there. This bit here needs to change because we need to. Instead of just storing the string, we're actually going to like parse it and validate it. So probably going to just have a very boring function that's like parse media type or something. Yeah, and then something like that. Something dumb, something easy. And then we're going to get back a media type and just in there. All right. So we have our now we should really put these things together. So parse media type. There we go. Okay, this is going to be very boring. Okay, so return. Just like this. Very boring. Let's do this. Let's do... did this. Okay, let's do some Acme X. Media type image, yeah, that's it. Okay, let's try that again. This book, hold on. Very boring code. Can't do 0. We're going to need to do... Oh, just error. Oh, whoops. Okay, so we're going to... No. And then we'll go... No. That's it. All right, so now when we actually parse the media line, so let me get the test data up just because that's going to be the easiest thing to do. All right, So what's going to happen is we're parsing this value here, audio, video, that sort of stuff. There's that and that. And we can get rid of that as well. So when we parse media, there, the type. So let's do var and media. Okay. And type is parse media type fields O. Easy. So m.type is, we can actually just do it just how we had it before. Type is there. Okay, whoops, let's get some tests going. All right. Oops. Oh, oops. Okay. Media. As string value. Oh yeah, okay, so now we need to modify our struct to be this. Keep that down here for now. Okay, so we've got our media. We go, type is media type. We can, there we go. Ah, okay, here we go. All right, so thank you, compiler. All right, now we can go. So media type audio. So again, so these are just our test cases, because before we were setting it as just a string of audio, but now that we actually have a real type, we're just going to rework our test cases to actually check, hey, like instead of finding the raw string video, what we actually want to see is our, our kind of enum, right? Go enums. There we go, and we're passing. All right, sweet. So that worked. Cool. There we go. That's so easy as that, I think, maybe. Oh, is there a delay? Shit, yeah. I can probably, okay, you know what? How much, can you tell me how much of a delay there is approximately? Like, do you think it's like 1 second, or is it much longer than that? Maybe 1 to 2 seconds. Okay. Give me less than 1. Okay. Okay. What I'll do then is I'll quickly go onto the the production head-end machine, and just I can manually delay the video at one end. So then at least it'll be in sync. 2 seconds. that should actually be better now. I hope. Yeah. So I'll just do a quick test. So I'm going to ls enter, enter, HELLO space WORLD, enter. How does that look? But better. Okay, cool. Okay, I can fiddle with it a little bit more, but yeah, I'm a bit pissed off about the way. Yeah, anyway, yeah, the way that the video and the audio comes from that camera to the machine is, yeah, not great. Yeah, right. Okay. Okay. I can. Yeah. The other thing I could do is just run a long HDMI cable out to there, but yeah, could do that. Nah, yeah, but I, you know, like, it's, like, that's also part of the work that we're doing, right? Is we're dealing with these kind of synchronization issues. So, yeah, it's sort of understanding how and what is going on is really part of it. I mean, I've literally written like an MPEG transport stream decoder, an encoder. So, like, in theory, I should be able to actually just use our software to read the stream of MPEG transport stream packets that we're getting from this camera, and, like, you know, like, find, yeah, you know, just try and troubleshoot what's going on. Okay. So, looks like that's all working. Read session, are we writing out sessions 2? And when you do it with time. Yeah. Well, look, I know that from where I am here to California, I can get about, like, there's not many hops in the network, so I should be able to get something like there. That's what we should be getting. So that's in Los Angeles, California. So. But yeah, we're getting a lot. Obviously, we get a lot of latency because we're doing Twitch and everything, right? So. Encode test. Cool. All right, that's that bit done. So let's. This is going to be like the media types. go. Cool, that's another to-do down. Awesome. All right. It's actually a lot better now. I'm not sure what I did. So on the machine running OBS, because in this one here, I'm sending the, doing an X11 grab of FFmpeg, encoding it as using the MPEG-2 codec, because that's very easy for this, not great CPU in this machine. And and then sending that to that machine over there. Using RTP. And so what I do is on the machine over there, I say, okay, like I manually put a delay in of 1 second, because I know that it seems the video, like the data from this camera to there, for whatever reason, takes about 1 second. So if I just delay how, the render delay for the video here, then it's roughly going to be in sync. It's not a very smart way of doing it, but it, kind of, yeah. Yeah, of course, the proper thing would be just to I don't know. I just don't know why the camera, it's something. So look, there's something with the way this thing transmits. It seems to send a lot of stuff out of order somehow. And so the receivers, particularly the FFmpeg, when it's reading the MPEG transport stream packets, it throws a whole bunch of errors, whoa, unexpected this one's way gone, so I'm not sure exactly what's going on there, but what I actually have to do is I'm playing this MPEG transport stream into VLC on that thing, and then using the VLC input in OBS to do it. Now, probably what I'd rather do actually in all of this is just switch from using OBS to just doing plain FFmpeg, because it's just, I don't know. Because I can just set, I can have the video in the corner and then have the main video in the background, and then it can just be static like that, and it's fine, And then I can transmit, I can send the video off over RTMP to Twitch anyway, so it's all right. It's fine. I can't do well, yeah, anyway. Yeah. Really what I'd rather do is probably transmit from the camera directly to this computer, but it probably can't really handle doing live H.264 encoding. So, yeah. But that would make the sync a lot easier, right? Because it's just one place to synchronize from. One less clock in the mix, I guess, is the thing. Yeah. Okay, cool. So let's send those changes up. Cool. Okay, and then now I'm 11:25. Yes. Okay, I'm just about on time. So yeah, I'm gonna time for me to go. I just need to go and just meeting up with my family for lunch. So yeah, hopefully my friend Nid the Noob is the username on Twitch. Hopefully they were here doing this. Listening. Let's see if they. And part of us went over my head. Yeah. Good luck with the domain. Thank you very much. Thanks. Yeah. Yeah. That's it really. Yeah. I'll just close this stuff up, and then thanks everybody for watching. I should probably. So if anybody's interested in seeing the code, there's going to be. There's the source code there. Yeah, it's good fun. Yeah, very, very fun to do this kind of thing in Go. It's great. Like feels very natural. Yeah. Yeah. Yes. Now the only thing that's left is we need to change the byte order in the audio. So we need to go from little endian to big endian. So I'm going to see if my friend can do that. I don't know how easy or hard that is, but yeah. Right now I just like convert it. Changing the endianness is easy. Yeah, I guess like, do you just go through each byte and just swap it around or something? Is that? Okay. I know there's a... yeah, I guess it'd be this one. So binary, no, in this case we want to go to big endian. So the network order I think is big endian, and at least on this operating system, on this and on Intel and ARM CPUs, it's little endian. And anyway, but yeah, it's stored in little endian here. I think you just need to convert it to big endian. Just because that's what's in the spec. So it says, L6 like this. I haven't got it here anymore, but the L16, transport profile for RTP or whatever they call it, like the way of transporting uncompressed audio over RTP must be done with big endian, I think. it's sort of little endian. Okay, on the network it will be big. Okay, right. Okay, cool. So maybe this one will do it. Because then I could rather than needing to worry about this thing, I can just go, so I'd do like, because my writer in this case is the, would just be my byte buffer. So maybe it would look like, so if I have a file here, so it would be like, binary.write buffer, and then it would be if I'm only dealing with 8-bit values, there will be no endianness. Dealing with 16-bit. Right. Okay. So then I would do, I think, yeah, big endian, yeah. So I would have and then binary dot big endian, and then the data would actually be I just have some here. So I need to read it into my own little thing first, I guess. So I'd have the size here, so I just do the size, whatever that is, I'll let the length. And then, which I think, you know, we did this number, right? It was like 3,000 and something, you know, like 3,240 or whatever it was. And then right, and then go like this, B, N, binary dot right, and then that would convert it. I think, but I'm not sure. But hopefully my the one who's actually writing the audio, like who's the one who's passing me the bytes in the first place, can do that for me. So hopefully my friend can do this. I don't know if that's really gonna converts of data into slice of fixed size value or pointer to such data. Yeah, Boolean values encoded 1 byte, retrieve bytes into W encoded center of the byte or running straight blank fill name. Yeah, right. Okay. Yeah, so maybe that would be it, but not sure. Maybe we could do it when we read it out again. Or the payload. Yeah, I don't know. I'm not sure. Am I familiar with the endianness problem? No, I don't think so. What is the endianness problem? Yeah. Okay. Cool. Just about. Because it's just, yeah, like the register, and then you can set the bits, and then... Oh. Okay. Mm-hmm. Yep. Okay. Yep. So if the most significant bit comes first, remember the big endian. Okay. Yep. 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 Okay. Okay. Mm-hmm. All bytes on the wire. From memory location 21012, I guess that, assuming we address by byte, we get 2. Location 2, assuming we address by byte, then we'll get 2, 3, 4, 5. Yep. If we loaded the memory address 2 to a little endian machine, the bytes would load into the register as 5432. Okay. Because from the network you don't know. Yeah, I got it. Yeah, right. Because because you don't know, right? Because the bytes coming in from the network are and the ambits is an issue. Yeah. I got it. Yeah. I think I get it, right? Because you don't know. Because if you just naively load it from, yeah. Oh, the registers are more than 1 byte. Okay. Oh, the registers are more than 1 byte. So the registers aren't 8 bits. Yeah, right. Okay. I understand. Yeah. Okay. So that's why, yeah, right. So that's how, yeah, right. So that's why it's big endian over the network. Yeah. No? Or is that just... No, big... Yeah, yep. Yeah, that's yeah. 5 seconds. 5 seconds isn't too bad. I'm surprised it's actually that low. Because the tech they use to, the stuff they use to deliver the video is very latency, introduces a lot of latency. Yeah, okay. Yep. Yeah. 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 Okay. Right. Okay. Yeah, because little n, because it's, yeah, it's not 8, 7, it's 7, 8. Yep. Okay. Right. Okay. 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 Yeah. Yeah, I guess like I'll probably yeah. Yeah, there's these, yeah. Well, I could probably, I mean, I feel like what I want to do is just say to the person who's going to give me, um, like, hey, like, please give it to me, big endian. Then you have to commit this endian SCD to work in a center. Yeah, yeah. No, no, look, that's actually great. Like, and no, 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 I understand, yeah, I understand more now, yeah. It's one of those things that, like, for me anyway, like, I'll understand it for, like a bit, and then you forget about it, and then you kind of don't understand it anymore, and then you come back, and then you have to kind of, but every time you kind of, yeah, every time you kind of, you you start with a little bit more of understanding than you had before. Yeah, agreed. Yeah, because there's stuff in some of the data structures that we're dealing with, the endianness really matters because we're dealing with weird like 15-bit, 33-bit values. So yeah, the endianness is important. And man, I was banging my head against this problem over and over, and I thought, wait, like, how do I load these bytes? Like what, like I'd forget like how to, like which order to load those 33 bits in. It was super annoying, but it was like educational, like great, wow. But it was sometimes you, yeah, you think you understand it, yeah. Yeah, it was yeah, not aligned on, yeah, had no byte alignment. Yeah. No, no, no. I mean, no, no. No, those are, yeah. Like if you look at the um there were timestamps stored as 33 bits. Um yeah, I tell me about it. It was super annoying, right? Like if you go to I'll show you. Yeah. So there was stuff that were like, and there were reserved bits and stuff like that. So you'd need to like load a 15-bit value into this thing that already has some bits reserved. So it was like loading each bit in, and it's, yeah. Yeah. and doing it in a way that's portable was, yeah. These bit, and then there was also yeah, there's a bunch of stuff in this package, in this Scutty 35 package, and also the other one that we wrote, MPEG Transfer Stream has that, yeah, in the it was all, yeah, I can't remember now. Yeah, here we go, this one. These things. That was a, yeah, this is the 33-bit thing. See? So it was, it's like a bit field, and then it was, right, 33 bits there. So 1, 2, 3, 7, 11, 15, 18, and then a marker. Or, well, I can't remember what that was, but this is like a reserved, like a check bit, I guess. And then again, you have, you know, you keep loading it in. So, yeah. It was, yeah, it was fun, right? So, yeah. I don't know, yeah. See, even now when I read this, I don't think, I'm not, I mean, I wrote this, of course, but I mean, it's just one of those things where, look, the other painful thing is that in Go, you don't have, like, there's no native bit field type or something like that. So, yeah, you kind of have to do, yeah. That one's a bit more commented, so kind of if I read through it slowly, I can get there eventually. Yeah. Anyway. When I think of you, where does memory value 0 live? On the left or the right? On the right. Oh. Ah, yeah. Okay. Yeah. I think so. I'd need to write some code to like experiment with it. Yeah. Yeah, but actually it's not. Yeah. So the biggest... Yeah. Yeah, because the significant is on the left. Yeah. 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 Okay. Yeah. Like that that's a good one. Yeah. Yeah, okay. Okay. Ah, because of memory. Yeah. Okay. So 4, 8, 12, 16, 20, 24, 32. Be sort of little ending, it would be 0. Four, 8, 12, wait, 4, 8, 12, 16, 20, 4, 8, 12, 16, 20, 24, 20, 32. Wait, 4, 1, 2, 3, 4, 5, 6, 7, 8, 9. F01. Right, yeah. Yeah. Yeah, little nibble, yeah. 1, 2, 3, 4, 5, 6, 7, 8, 9, 9, 4, 36, yeah. 2, 3, 4, 5. Awesome, yeah. Yes, and you know, I have to go and meet my family for lunch, so hey, listen, Omnifidus, thank you very much for your time. Yeah. Thanks again, that's super helpful. Thank you very much. Thanks very much. Ah, cool. Yeah. Oh, nice. Oh, thanks very much for stopping by. That's awesome. Thank you. Yeah. No, thanks very much to you too. Okay. Yeah, better go. Otherwise I get in trouble. Okay. Thanks very much. Thank you again. Cheers. See you. Okay, that one. Bye.